when we look at turboprop aircraft, for example, we can control the pitch of the prop using the condition lever or sometimes using the power lever. So, for example, if I want to go to the maximum course angle, okay, which is feather, I can bring the condition lever all the way back here to feather. If I want to go to superfine, I'll bring the condition lever right up to fine position. So this is the maximum course. This is the maximum fine position. If I want to go to reverse pitch, I need to bring. We would probably be on the ground. So when we're on the ground, we wouldn't be at max RPM. So we bring our RPM gauge back here, say to minimum, and then we would bring the power lever back into what's called the beta range. And when we're on the ground, the power lever then controls the pitch of the prop. So when I come down in here, once I go beyond superfine, the pitch of the prop is controlled by the power lever. Okay, so we have two modes. The alpha mode, the condition lever changes the pitch of the prop. So that's when we're in the air, alpha for air. And the beta mode is when we're on the ground, and the power lever then changes the pitch of the prop when we're on the ground. All right. So when we're in the air, what pitch do we want our propeller to be? So it all depends on the advance ratio. So if we want to have the maximum efficiency, so the efficiency of the prop is related here to the advance ratio. So if we want to maximize efficiency, we want to have maximum advance ratio. But you can see here, when we have advance ratio and efficiency, you can see that for a particular advance ratio, we need a particular blade angle. So, the pilot who's flying the aircraft, he is looking at the relationship between the velocity and the RPM. So if as we change the blade angles, we're ultimately controlling the revs of the engine. This small n is revs per second. So to get the maximum efficiency, it's finding that sweet spot between the velocity and the aircraft velocity and the revs per second. So it would be nice then if this was constant. If we could keep this constant, then the advance ratio is only a function of the velocity of the aircraft, which is the airspeed indicator. And that's what a constant speed propeller does. So with a constant speed propeller, the RPM is kept constant. So this value here, the revs per second times the diameter of the prop, this is kept constant. So when the pilot pushes the power lever forward, okay, to increase velocity, the propeller blade angle automatically changes. Okay, so it increases in this case to make sure that this value stays the same. And it goes to a position where the angle of attack is at its optimum point. So it's at the optimum point between velocity and RPM. So that's what a constant speed propeller does. So constant speed propeller ensures that the propeller rotates at a constant speed. So if we push the power lever forward, and I'll just do that again, the condition lever hasn't moved, okay, so that we're in the constant speed range, so the pilot pushes the condition lever into the constant speed range. Then when he pushes the power lever forward, the propeller changes pitch automatically to make sure we keep the same RPM. Okay. And if we were to plot that on a graph, so, let's say we have a particular blade angle, so we're starting at, maybe a very fine angle, and, we increase the power lever. So as the power goes up, the RPM will go up. We'll just look at that again. So we're at 500 RPM. We increase the power lever, the RPM will go up, but the blade angle remains the same. When we get into the constant speed range, then when we push the power lever forward again, okay, so the power lever has gone up, the blade of the angle has changed, but the RPM has remained constant. And eventually we get to a speed or a setting that is outside the constant speed range. And after that then, as the fuel flow increases, the blade angle will continue to increase and the RPM will start to increase also. So there is a range within the condition lever where the RPM can be held constant. And that just makes it easier for the flight crew to get the optimum